In the previous chapter, we have discussed about the spatial interpolation, how the process of spatial interpolation is taking place and how important the spatial interpolation is useful in GIS. In this chapter, we will discuss about the geocoding and the dynamic segmentation. Geocoding, variations in geocoding, applications of geocoding, dynamic segmentation, applications of dynamic segmentation. To locate an address in an unfamiliar city, we browse into Google Maps and zoom into the closest street direction. Along with the direction of the address, we will get to view the surrounding of those street route. Although not apparent to us, this route activity involves geocoding, the process of plotting street address or intersection as point features on a map. Geocoding has become perhaps the most commercialized GIS related operation. Like geocoding, dynamic segmentation can also locate spatial features from a data source that lacks X and Y coordinates. Dynamic segmentation work with data such as location of traffic accidents, which are typically reported in a linear distances from some known place. Dynamic segmentation is popular with government agencies that produce and distribute spatial data. Many transportation departments use dynamic segmentation to manage data such as speed limits, rest areas, bridges and pavement conditions along highway routes. Natural resource agencies also use dynamic segmentation to store and analyze stream research data and aquatic habitat data. Geocoding. Geocoding refers to the process of assigning a spatial locations to a data that are in tabular format but have fields that describe their location. According to Crook, geocoding started during the 1960s, the same time as GIS, when the Youth Census Bureau was looking for ways of mapping surveys data gathered across the country, address by address. The most common type of geocoding is address geocoding or address matching, which plots street address as point features on map address. Geocoding requires two sets of data. That first data set contains individual street address on a table, one record per address. The second is the reference database that consists of a map and an attribute for each street segment such as the street name, address range, zip code. Address geocoding interpolates the location of a street address by comparing it with data in the reference database. Geocoding reference database. Reference database must have a road network with appropriate attributes for geocoding. Many GIS users in the United States derive a geocoding reference database from the Tiger or line files, which are extracts of geographic or cartographic information from the Youth Census Bureau master address file or topological integrated geographic encoded and reference database. The Tiger or the line files contain legal and statistical area boundaries such as the county census tracts and block groups, as well as streets, roads, streams and water bodies. More importantly, the Tiger or the line attribute also includes for each street segment the street name, the beginning and the end address numbers on each side and the zip code on each side. The address matching process. The geocoding process uses the geocoding engine, which can be embedded in a GIM package. In general, the geocoding process consists of three phases: the pre-processing, the matching, the plotting. The pre-processing phase involves the phasing and addressing standardization. The phasing breaks down an address into a number of components. The result of the phasing process records in which there is a value of each of the address components to be matched. Reference database can have its own set of problems as well. Reference database can be outdated because it does not have information on new streets, street name changes, street closing, incorrect zip codes. Address matching option. A geocoding engine must have options to deal with possible errors in the address table, the reference database, or both. Typically, a geocoding engine has provisions for relaxing the matching conditions. ArcGIS, for example, offers the minimum candidate score and the maximum match score. The former determines the likely candidates in the reference database for matching, and the latter determines whether an address is matched or not. Adopting a lower match score can result in more matches but also introduce more possible geocoding errors. ArcGIS, however, does not explain exactly how the scores are tabulated. Offset plotting options. The side offset and the end offset are options that allow a geocode address to be plotted away from its interpolated location along its street segment. The side offset places a geocoded point. It is specified distance from the side of a street segment. This option is usually for point in polygon overlay analysis, such as linking address to census tracts or land parcels. The end offset places a point feature at a distance from the end point of a street segment, thus preventing the geocode point from falling on the top of the cross street. The end offset uses a distance that is given as a specified percentage of the length of the street segment. Quality of geocoding. The quality of geocoding is often expressed by the match rate or the hit rate. What is an acceptable hit rate? Various tools are available for improving the accuracy of the address matching. They include standardizing address to the USPS format and using internet mapping engine such as Google Earth Pro. The USPS offers software vendors the coding accuracy support system to test their address matching software against the test address. Besides the hit rate, position accuracy has also been proposed to access the quality of geocoding. Weighted positional accuracy is measured by how close each geocode point is to the true location of the address. Because of geocoding errors, Davis and Fonseca have proposed to geocoding certainly indicator based on the degree of certainty during 3 stages of geocoding process. According to this study, the indicator can be used either as a threshold beyond which the geocoded result should be left out of any statistical analysis, or as a weight that can be incorporated into spatial analysis. Variations of geocoding. Intersection matching, also called the corner matching, matches address data with street intersection on a map, and address entry for intersection matching must list 2 streets. Geocoding engine find the location of the point where the street intersect. The intersection matching is a common geocoding method for a police collision report data. Like address matching, intersection matching can run into problems. A strange intersection may not exist and the difference database may not cover new or renamed street. A winning street crossing another street more than once can also present a unique problem. Additional data such as address numbers or adjacent zip codes are required to determine which street intersection is to plot. Zip code geocoding matches zip code to the code centroid location. It differs from the address matching or the intersection matching in 2 ways. First, it is not the street level geocoding. Second, it refers reference database that contain x and y coordinate either geographical or projected rather than the street network. Parcel level geocoding matches parcel number to the parcel centroid location, and if the parcel database available plots the parcel boundary. Reverse pseudo geocoding is a reverse of address geocoding, that is, it converts point location into descriptive address. Place name alias geocoding matches a place name such as well-known restaurant or a museum with a street address. Locate the street address and plots it as a point feature. It requires a place name alias table complete with place names and their street address. Photo geocoding attaches location information to photographs. Photographs taken with digital camera with built-in GPS can have associated longitude and latitudinal readings. Photo geocoding uses the geographic coordinates to plot point location. Applications of geocoding. Geocoding is perhaps the most commercialized GIS related operation. It plays an important role in location based services and other business applications. Geocoding is also a tool for wireless emergency service, crime mapping and analysis, and public health monitoring. Location based services. Location based services refers to an service or application that extends spatial information processing to an end user via the internet and or the wireless network. Early examples of location based services relied on the computer access to internet. The current popularity of the location based services ties to the use of GPS and mobile devices of all kinds. Mobile devices allow us users to access the internet and location based services virtually anywhere. In mobile phone, user can now be located and can receive location information such as a nearby ATM or restaurant. Other type of services include tracking people, tracking commercial vehicles, routing workers, meeting customer appointments, and measuring and auditing mobile workforce productivity. Business application. For business applications, geocoding is most useful in matching the zip codes of customers and the prospects of the census data. The census data such as income, person population in different age groups and education levels can help business prepare promotional mailing that are specifically targeted their intended recipients. Other business applications include site analysis and market area analysis. Telecommunication providers can also use geocoded data to determine appropriate infrastructure placement for expanding the customer base. Wireless emergency services. A wireless emergency service uses a built-in GPS receiver to locate a mobile phone user in need of emergency dispatch service. This application is enhanced by 2001 mandate by Federal Communication Commission, commonly called Automated Location Identification, which requires that all wireless carriers in the United States provide a certain degree of accuracy in locating mobile phone user who dial 911. Crime mapping and analysis. Crime mapping and analysis typically starts with geocoding. Crime record almost always have street address or other location attributes. The geocoded crime location data are input to a software packages such as crime set for hotspot analysis and space-time analysis. Using historical crime data of software packages can also forecast the number and the types of crimes that can occur within a neighborhood. Public health. Geocoding has become an important role for research in public health and epidemiology in recent years. As part of their public health surveillance activities, health professionals use geocoding according to locate and identify changes in patterns of human diseases. Geocoding can also be used to derive neighborhood socio-economic data for cross-sectional analysis of public health or valence data and to provide input data for measuring geographic access to health services based on the travel time and distance between the subjects and medical providers. Dynamic segmentation. Vector data used in GIS are two-dimensional data measured in x and y coordinates. They are, however, data that are linearly measured. For example, highway accidents. Unless the location of the linearly measured data is provided, the data cannot be used in GIS environment. To understand dynamic segmentation, route and event must be introduced first. A route is a linear feature such as a street, a highway or a stream used in GIS, which also has a linear measurement system stored with its geometry. Events are the linear reference data such as speed limits, traffic accidents or fishery habit conditions which occur along the routes. Dynamic segmentation can be defined formally as a process of computing the location of events along a route. Thus, through dynamic segmentation, traffic accident location can be computed a run time from the linearly referenced data and plotted along an route highway. Application of dynamic segmentation. Dynamic segmentation can convert linearly reference to data stored in tabular reports into events along routes. Once these data are associated with routes, they can be displayed, queried, analyzed in a GIS environment. Data management. From the data management perspective, dynamic segmentation is useful in two ways. First, different routes can be built on the same linear feature. A transit network can be deployed for same street database for modeling transmitted demand. Similarly, multiple trip paths can be built on the same street network, each with a starting point and an ending point to provide disaggregate travel, date of travel, demand modeling. Second, different events can reference the same route or more precisely the same linear measurement system stored with the route. Dynamic segmentation is an efficient method for delivering hydrologic data sets and for locating features along the highway routes. Data display once an event table is linked to a route to a table is georeferenced and can be used as feature layer. This conversion is similar to geocoding an address table or displaying a table with x and y coordinates. Data query, both attribute data query and the spatial data query on event table and its associated event layer can be performed in dynamic segmentation. For example, we can query a point event table to select recent traffic accidents along the highway route. The attribute query result can be displayed on an event table as well as an event layer. To determine if these recent accidents follow a pattern similar to those of the past accidents, data query can also be performed on a route to find the measure value of a point. This is similar to clicking a feature to get the attribute data about the feature. Data analysis. Data analysis, both routes and events, can be used as inputs for data analysis. For example, study the efficiency or equity of the public transit routes. We can first buffer the routes with the distance of half mile and overlay the buffer zone with census blocks or block groups. We can then use demographic data from the buffer zone for the planning and operation of the public transit system. Events, after they are converted into an event layer, can be analyzed in the same way as a point or linear feature layer. Data analysis can be performed between two event layers. Thus, we can analyze the relationship between the traffic accident and the speed limits along the highway route. The analysis is similar to the vector-based overlay operation, that is, the output layer shows the location of each accident and its associated legal speed limit. A query on the output layer can determine whether accidents are more likely to happen on versions of the highway route with higher speed limits. However, data analysis can become complex when more than two event layers are involved. In each layer have a large number of sections. Summary: geocoding is a process of transforming a description of a location such as a pair of coordinates, an address or a name of a place to a location on the Earth's surface. You can geocode by entering one location description at a time or by providing many of them at once in a table. The resulting locations are output as geographic features with attributes, which can be used for mapping or spatial analysis. From simple data analysis to business and customer management to distribution techniques, there are a wide range of applications for which geocoding can be used. With geocoded address, you can spatially display the address location and recognize patterns within the information. This can be done by simply looking at the information or using some of the analysis tools available with ArcGIS. Dynamic segmentation is a classic GIS tool for analysis of roads, pipelines and railroads used in transportation and utility network application. The dynamic segmentation process generates point or linear geometry for database record event referenced by their position along a linear feature. Segmentation is a key component of the object-based classification workflow. This process groups neighboring pixels together that are similar in color and certain shape characteristics. In addition, you can use the dynamic segmentation boundaries only option if you want to display the segment as polygons with the source image visible underneath.